Hey guys, we're going to continue reviewing for your calculus final exam. Today we will look at the key concepts from chapters 3, 4, and 5. Now chapter 3, this was when we got to start working with different rules when doing a derivative. So we looked at things like the product rule, the quotient rule, and the chain rule. Now on your final, there is a cheat sheet that does have these three formulas on them. So don't worry, I know it's been a while if you don't remember exactly how the rule works. As long as you can follow along with the rule and get to that derivative, you're going to be fine, okay? So let's go ahead and practice some of these. So if I have 4x minus 1 times 3x plus 1 to the power of 4, in order to find the derivative, you would have to use the product rule. Now remember the product rule, f of x is the first piece. So in this case, it's the binomial 4x minus 1. Now g of x is the second piece. So in this case, it's 3x plus 1 to the power of 4. Now, when you're doing the product rule, we have two different chunks and they're separated by a plus sign. The first chunk, you keep f of x the way that it is. So 4x minus 1 would stay. Then you multiply it by the derivative of g of x. Now, this is going to be the general power rule. I would bring the 4 out front, keep 3x plus 1 the same, reduce the exponent down to a 3, then you multiply by the derivative of the inside, which is a 3. So that's the first piece. Plus, now I go to the second piece. You keep g of x the same. So 3x plus 1 to the power of 4. And you multiply it by the derivative of f of x, and that's a 4. Now the product rule is where you want to look and see what they have in common and divide out that greatest common factor. So both groups have 3 of the binomial 3x plus 1. This group has 4, but this group only has 3. So when I take out the greatest common factor, I can only remove 3. Both groups also have a 4. So the 4 and the group 3x plus 1, we're going to take out 3 of those. So what I have left, I took this out and I took this out. So I have 3 times the binomial 4x minus 1. 3 times 4x is 12x. 3 times negative 1 is negative 3. Plus, now here I took out the 4 and I took out 3 of the groups 3x plus 1. So all I have left is my 3x plus 1. Your final answer, we just have to simplify what's in the brackets. So I have a 4, 3x plus 1 to the power of 3, combine like terms, 12x plus 3x makes 15x, negative 3 plus 1 is a negative 2. That is your derivative using the product rule. Okay, next one. Now the quotient rule, you have to have a quotient, meaning you're dividing. When you do the quotient rule, f of x is whatever's on the top. So x squared minus 6x. Now g of x is whatever's on the bottom. It's x minus 2. So again, you just have to be able to go through this formula. On the top, we're going to look at two pieces. This time they're separated by a minus sign. In the first chunk, you keep g of x the same, so x minus 2. Then you take the derivative of f of x. That would be 2x minus 6. That's the first chunk on the top. Minus, now you keep f of x the same, x squared minus 6x. Multiply that by the derivative of g of x, which is just a 1. So what I'm going to do now is simplify the top. I know I'm not done because I do have to go ahead and take my original g of x and square it for the denominator, but I will need to simplify this, so I'm going to go ahead and do that right away. These are two binomials that you want to multiply together, so I'm going to FOIL them. 2x squared minus 6x minus 4x plus 12. So this first chunk is 2x squared, negative 6x minus 4 more x is negative 10x plus 12. That's the first chunk. Minus, now if I multiply by a 1, nothing's going to change. 1 times x squared is going to remain x squared. 1 times a negative 6x is going to stay negative 6x. Okay, now what I have to do is subtract like terms. 2x squared minus 1x squared is 1x squared. Negative 10x minus a negative 6x. If you minus a negative, you're actually adding. So negative 10x plus 6x is negative 4x plus 12 over your original g of x, which is x minus 2 quantity squared. That is your derivative, which remember from chapter 1 is when they first introduced derivatives. That's the formula used to find the slope of a tangent line at a point. You could fill in any x value and you'd be able to find that slope. Okay, next one. Now, when you're doing the chain rule, this is the first time during the year that we looked at like decompositions. So we have an outside function and an inside function. So if I am looking at h of x was created by having f of x as the outside function and you filled in g of x. So f of x, the outside function, is x to the power of 5. G of x, what you filled in instead of x, is 2x cubed minus 5. So it's important to be able to identify those two different functions that were put together to create that composite function. Now here is the formula. We need the derivative of f of x. So I bring the 5 out front, but instead of x, you're replacing it with the original g of x. So 2x cubed minus 5, but it would be to the power of 4 because your derivative of f of x would be 5x to the power of 4. So the 5 and the 4 are there, but x becomes your original g of x function. Then you multiply it by the derivative of the inside, which is 6x squared. So I can write this in a more simplified term. I can take the 5 and the 6x squared and multiply them to get 30x squared times 2x cubed minus 5 to the power of 4. That would be your derivative. Okay, one more question and we will wrap it up for chapter 3. If you are finding the equation of a tangent line, this was something that came up a lot during the first half of the year. In order to find an equation, you do need two things. You need to know a slope and you need to know an ordered pair, okay? So this says, find the equation of the tangent line. Here is the graph. They want us to find it at the point where x is equal to negative 1. Well, one of the things you need to know is an ordered pair. In order to find the y value for an ordered pair, you fill the x value into the original function. So I'm going to go ahead and do that. If I fill in a negative 1 cubed minus 1 times negative 1 squared plus 1 to the power of 4. This is going to help me find the y value. Negative 1 cubed, negative 1 times negative 1 times negative 1, well, that's negative 1. Minus 1 more, this is negative 2. So that's the value of this first set of parentheses. Now here, negative 1 squared. If you square a negative, it ends up being positive. So negative 1 squared is 1. 1 plus 1 is 2. 2 to the power of 4 is 16. So what I have here is negative 2 times 16. That's a negative 32. So that is the y value. So now I have an ordered pair. Again, if you know x, you put it into the original function. Whatever the value is, that is the y value. Now what I need to know is the slope. You have to know m. Well, in order to find the slope, I have to find the derivative of this function and then fill in our x value. In order to find the derivative of this, it is the product rule. So f of x would be the binomial x cubed minus 1. G of x would be x squared plus 1 to the power of 4. Product rule. I keep f of x the same. X cubed minus 1 times the derivative of g of x. 4 times x squared plus 1 to the power of 3 times the derivative of the inside, which is 2x, plus, now what I have to do is go ahead and look at that second chunk. I'm just going to make sure that I don't run into that. Okay, the second chunk, I keep g of x the same. So I have x squared plus 1 to the power of 4 times, oh, I'm good, times the derivative of f of x, which is 3x squared. Okay, so I have my two groups. Now remember product rule. This is where you want to look and see what they have in common. Well, I know that they both have at least 3 of the group x squared plus 1. This piece, this chunk has 3 of that binomial. This chunk has 4. So I will be able to remove x squared plus 1 to the power of 3. I can take out 3 of them. That way I'd only have 1 left. The other thing that they have in common, this has a 2x, this is a 3x squared. They both have 1x in common. So I can remove that x. This was 2x's, now it's down to 1. So again, it's the product rule. That's the one where you want to take out what they have in common. Now you have to figure out what do you have left. I have a 2 and a 4. 2 times 4 is 8, and we would be multiplying that by the binomial x cubed minus 1. Okay, so again, I have a 4 and a 2 remaining. 4 times 2 is how I get an 8. I still have the binomial, my original f of x, x cubed minus 1. So if I distribute, 8 times x cubed is 8x cubed. 8 times negative 1 is negative 8. Now I go to the next piece. I still have one group of the x squared plus 1, and I have a 3x remaining. So I have to distribute because it's one term times two terms. So this is 3x cubed. 3x times 1 is 3x. Now what I need to do is go ahead and combine the like terms because that will allow me to simplify this. 8x cubed plus 3x cubed is 11x cubed. I have a 3x and minus 8. Now this is the derivative. Remember your derivative, it is the formula for the slope if you have the x value. So this is how I'm going to find the slope. I want the slope when x is negative 1. So x is a negative 1. If I put a negative 1 in here, negative 1 squared, negative 1 times negative 1 is 1. 1 plus 1 is 2. 2 to the power of 3 is 8. Now if I put a negative 1 in here, this would become a negative 11 because negative 1 times negative 1 times negative 1 is negative 1 times 11 is negative 11. Positive 3 times negative 1 is negative 3 minus 8. So I have negative 1 times 8, negative 11 minus 3 more, minus 8 more, we get negative 22. So if I multiply these together, negative 1 times 8 times negative 22, that's 176. So that is the slope, okay? What this question is asking for is what is the equation of the tangent line? I have a point, I have a slope. That's all that I need in order to go ahead and make an equation. So it's y minus the y value from the ordered pair, which is a negative 32, equals m. M is the slope, 176. X minus the x value from the ordered pair, that's a negative 1. Minus the negative here, that is actually a plus. In the parentheses, I minus the negative value, that changes to a plus. Distribute to cancel the parentheses. Y plus 32 equals 176x plus 176. Last step. I'm going to minus the 32 to this side. That will isolate the y. Y equals 176x plus 144. That is the equation of the tangent line of this graph if you go to the left 1 unit and draw a tangent line. And you guys, that is chapter 3. Let's go ahead and look at chapter 4. Now chapter 4, this was where some of you started really having fun. This was the chapter where we really looked at like those exponent properties. So remember, if you want to simplify this to a single term, what you want to do is make a common base. So 4 can be turned into 2 squared. You would still have the x on the outside. 8 can be turned into 2 cubed. You would still have the x on the outside. 2 has a 3/2 x. Okay, now remember, exponent properties. You multiply inside and outside exponents. So this would be 2 to the power of 2 times x, that's 2x, times 3 times x gives you 3x, times 2 to the 3/2 x. Okay, so what I did there is I created a common base. Now we have that property that says if you have the same base, you can write it one time. So I can write just 1, 2. Multiplication goes with addition. So I add those exponents together. So 2x plus 3x plus 3/2 x. Well, in order to do this, we're adding a fraction. So I have to make this a common denominator. I need a denominator of 2. So 2 becomes 4/2 x. 3 becomes 6/2 x plus 3 over 2x. So my base is a 2. I have a common denominator in my exponent. I know what I'm doing is adding the common term that has an x. 4 plus 6 is 10, plus 3 is 13. So your solution is 2 to the power of 13 over 2x. This was fun stuff. And if you remember back in chapter 4, a lot of the assignments, they had you make a common base of either 2's or 3's. Also in chapter 4, we talked about how you can simplify logarithms and natural logs. And so remembering that if you are adding, you're multiplying. If you're subtracting, you're dividing. Any number out front is actually an exponent. So this is really the natural log of x plus the natural log of y minus the natural log of z squared. Remember, anytime you have a log, and that includes a natural log, if there's an exponent, it goes out front. So if I'm condensing this and simplifying, we want to go in reverse. So I'm going to take that 2 and send it back to the z. Now, because this is a natural log, this is a natural log, and this is a natural log, I can write it as 1. I'm adding the x and the y. That means you're multiplying them. So x times y. Minus means you're dividing. You're dividing by z squared, and you're done. So that is called condensing logarithms. And turn page. Okay. You can solve exponential equations if you can condense it so this side has one base and this side has one base. If the bases match, you can totally just cross them off, okay? So again, these are all bases of 3. So what I'm allowed to do is write one base of 3 and you add the exponents. Now these exponents are not like terms. So when I add them, I'm gonna go ahead and put them in standard form. So I'd have an x squared plus a 5x plus 3 equals 3 to the negative power of 3. So this is what they mean. If you can simplify it, so you have one x or one base here and one base here. If those bases are the same, you get to go ahead and cross those off. So what I have is the equation x squared plus 5x plus 3 equals negative 3. I know I'm going to be finding 2 solutions because that fundamental theorem of algebra, I have a degree of 2. So I'm going to set it equal to 0 if I add the 3 over. X squared plus 5x plus 6 equals 0. I can factor this. 2 numbers that multiply to 6 and add to 5, well, that's 2 and 3, because 2 times 3 is 6, and 2 plus 3 is 5. So now to find the solutions, you take each factored group. So I'm taking x plus 2, I set that equal to 0. Take x plus 3, set that equal to 0. Now solve these equations, and those are your solutions. So the first one, I would minus 2. 0 minus 2 is negative 2. The second one, I would minus a 3. 0 minus 3 is negative 3. Another thing that we talked about in chapter 4 is how an e and a natural log, they undo one another. So if you can ever get e and natural log next to each other, you can just cross them off. Here, though, you would want to condense these natural logs first before you would cross that off, because otherwise you're going to get stuck. But I can condense these because this is a natural log and this is a natural log. So what I can do is write it as 1 natural log. Remember that subtraction goes with division. So this is the natural log of 3x divided by 4 equals 1. So step 1, I took the natural log of 3x minus the natural log of 4, wrote it as 1 natural log. Subtraction goes with division, so I took 3x divided by 4. Now, e and natural log are next to one another. They cancel. What I have remaining is 3x over 4 equals 1. To cancel the fraction, multiply both sides by 4. So 3x equals 4. To solve for x, divide by 3, and x equals 4/3, and you're done. Okay, let's look at another one. One of the big things for calculus, and obviously you're going to be seeing that as we go through the review. One of the main takeaways that you need to be comfortable with after completing Calculus 1 is being able to find the equation of tangent lines. That's one of the main things that as you go on into Calculus 2, that they're going to assume that you really are comfortable with. Okay, so I wanted to make sure that when we reviewed, I really did hit that concept kind of hard, just to make sure that you're still comfortable with this idea. So here is the next one. Can you find the equation of a tangent line if this is your curve and here is your point? Okay, so we have our point. We know our x and our y. But what we have to find still is m. In order to find m, you have to find the derivative and then fill in our x value, which in this case happens to be a 0. So this is going to be the quotient rule. F of x is whatever's on the top, so it's e to the power of x. G of x is whatever's on the bottom, so it's 1 plus e to the power of x. Quotient rule. You keep g of x the same. You multiply by the derivative of f of x. The derivative of e to the x is e to the x. Minus. Now you keep f of x the same, and you multiply by the derivative of g of x. Well, the derivative of a 1 is a 0. The derivative of e to the x is e to the x. So again, I'm going to simplify the top before I worry about the bottom. This is 2 terms being multiplied by 1 term, so I have to distribute. 1 times e to the x is e to the x, plus e to the x times e to the x is e to the 2x, minus e to the x times e to the x is e to the 2x. So I can simplify this. I have a positive e to the 2x minus e to the 2x. Those are opposites. When you add them together, they become 0. So all I have on the top is e to the x. The bottom is g of x, 1 plus e to the power of x squared. This is the derivative. Now the question is not asking for the derivative. The question is saying, hey, let's find the equation of a tangent line. So if I want to find m, I have to take the derivative and fill in the x value, which is 0. So e to the power of 0 over 1 plus e to the power of 0 squared. Remember, anything to the power of 0 is a 1, even if it's a base of e. Anything to the power of 0 is 1. So this is a 1. E to the power of 0, this is also a 1. So 1 plus 1 is 2. 2 squared is 4. So the slope is 1/4. The point is 0 and 1/2. Once you know a point and you know a slope, you can use point-slope form in order to get the equation of the line. So it's y minus the y value for the ordered pair, it's 1/2, equals m. M is 1/4. X minus the x value for the ordered pair, which is a 0. Distribute the 1/4, so y minus 1/2 equals 1/4 x. 1/4 times 0 is 0, so I'm not even going to worry about showing that. Add my 1/2 to the other side, because that way I have isolated my y. So my solution in y equals mx plus b form is y equals 1/4 x plus 1/2. That is the equation of the tangent line. Okay, and a couple more questions and we will be on to chapter 5. When you are finding the derivative of the natural log, remember the derivative of a natural log is 1 over x. If this is more than just an x, that's that chain rule. So what it ends up being is 1 over whatever this is. It's 2x squared plus 1. But because this is more than an x, now you have to multiply by the derivative of the bottom, which in this case happens to be 4x. So your solution is 4x over 2x squared plus 1. Chain rule. Okay, let's look at the last one. This is the product rule because this first piece contains a variable. This second piece contains a variable. So we are looking at the product rule with e's and natural logs. F of x is e to the x because it's the first piece. G of x is the natural log of 2x. When you are doing the product rule, you keep f of x the same, multiply by the derivative of g of x, so it's 1 over 2x. Because this is more than an x, now I multiply by the derivative of 2x, which is a 2. Plus, now I keep g of x the same, the natural log of 2x, times the derivative of f of x, the derivative of e to the x is e to the x. Now what I do is I look and see what they have in common. This piece has e to the x, this piece has e to the x. So I can take e to the x out. Now looking at simplifying, this 2 can cross cancel this 2. So what I'd have left in the first piece, e to the x is taken out. The 2's are cross canceled, so I just have 1 over x. Plus sign, e to the x is taken out, so what I have left is the natural log of 2x. That is your derivative. Okay, and before we go to chapter 5, it's time for a little mathematical joke. What do you call the number 7 and the number 3 when they go out on a date? Any guesses? The odd couple. Get it? The odd couple? Okay, let's go. I'm sorry. I'm trying to make these more entertaining for you. All right, let's go ahead. We have half a page left, chapter 5. This is a big question when we get to number 2. Really make sure that you understand how I'm getting those values. If you have any questions, send me an email or send me a message and I'll help you out, okay? All right, chapter 5 were some application problems. This says the size of an insect colony T days after its formation can be given by this function. So being able to look at a function like this and just answer various questions. What is the initial number of insects in the colony? Well, the number in front of E is always your initial amount. So in this case, we started off with 1,000 insects. What is the value of our growth constant? The growth constant is always represented as a decimal, and it comes before your variable. So in this case, our growth constant is 0.2, which means that the insect population is growing at a rate of 20% per day. Approximately how many insects are there after 10 days? Well, this is in terms of days. T is representing that number of days. So for part C, T equals 10. So I have 1,000 e to the 0.2 times 10. You just got to plug that into your calculator. You would find that it's approximately 7,389 insects. So you will see a question similar to this on the final. If I give you an exponential function that's pertaining to a real life scenario, could you tell me the initial amount? Could you find the growth constant and then be able to do a calculation? The other thing from chapter 5 that you will see in the final is being able to read a graph that has both the original function as well as the derivative. So you have to remember that the original function, depending on what it is, in this case we're looking at temperature. This is the temperature change, or what the value of the temperature is. Your derivative is the rate. How fast is it changing? Anytime it says rate, that's going to be kind of your key that you're looking at the derivative. So let's go ahead and do this problem. If you understand this one, feel really good about chapter 5, okay? When a rod of molten steel with a temperature of 1800 degrees Fahrenheit is placed in a large vat of butter. Just kidding. Haha, making sure you're paying attention. In a large vat of water at a temperature of 60 degrees Fahrenheit, the temperature of the rod after t seconds is given by this function. That's what they graphed. What it's representing is the temperature. Your y value is the temperature. Your x value is the time in seconds. Okay. What is the temperature of the rod after 11 seconds? If you are looking for the temperature, you're reading the original graph, your f of t. So 11 seconds. 1, 2, 3, 4, 5. So I'm just double checking. They are numbering by ones. So at 11 seconds, we are right here. You want to go ahead and see what the temperature would be. This is going by 100s. 100, 200, 300, 400, 500. So at 11 seconds, the temperature of the rod is approximately 400 degrees Fahrenheit. At what rate? When you see the word rate, what that means is you're focused on the derivative, so we have to look at that graph. We're looking at the graph of the derivative. At what rate is the temperature of the rod changing after 6 seconds? So after 6 seconds, we are right here. It is below the x-axis, so the rate, it is dropping at a rate of 100 degrees per second. Another way that you could do that, rather than writing the word dropping, you could put negative 100 degrees per second. But you would need to know that this is a negative value, whether you write the word dropping or you put in a negative. Either one is awesome, okay? Approximately, when is the temperature of the rod 200 degrees Fahrenheit? So temperature, that's our original function. We want to know when it's 200. These are going by 100s. So 100, 200. When is it 200? At approximately 17 seconds. Approximately, and the reason why they're saying approximately so much is because you're reading a graph, okay? Obviously, you're doing an estimation, doing the best you can, okay? So don't worry about it being exact. If you looked and you're like, whoa, I thought it was 16.8, great, because 16.8 is approximately 17, okay? So that's the deal with this word that keeps showing up as you're reading graphs. Let's do the last question of the day, guys. Approximately, when is the rod cooling at the rate? Derivative, when is it cooling at the rate of 200 degrees Fahrenheit per second? So it's cooling. That means it's dropping. So that means you're looking below the x-axis, 200, 100, 200. It is dropping at 200 rate or 200 degrees Fahrenheit per second at approximately 2 seconds. So guys, that is our review for chapters 3, 4, and 5. We have one more review to look at tomorrow, and then you'll be taking your final and you'll be done with calculus. I hope you are all doing well. I miss you so very much, and I'll talk to you tomorrow. See ya.